So this, ironically, is the end of, ironically in the sense that we did it very quickly because it's supposed to be a review of their classical laminated plate theory. So to do your homework, you need to know all this and have a program that does most of this. And eventually for the course, you need a program that will do all of this. We'll talk about software on Monday briefly. Let's talk now about failure, because everything we said tells us how to determine stiffnesses, how to determine strains given loads. So, okay, once you got your strains and your stresses potentially, how do you relate those to the strength of the structure and how do you predict failure? So, one method is what's called the use of first ply failure criteria, or open parentheses for the non-Greeks in the audience. The word in singular is criterion, coming from the Greek word criterion, and in plural is criteria, which is many of them. So this means there's many criteria or many ways of predicting failure, as we're about to see. So being Greek myself, I do have a little bit of a partiality on this term being used correctly. Not that I will take off points unless you do it too many times, and then my patience is exhausted. What you see here is the 787 wing box after the test. And you see the failure here, which is very close, I think, to the butt line 0, or the very main center of it. I'm not sure exactly where it is. They always make it a point, Boeing and Airbus, to take photographs that are very difficult to deduce where you are in the structure, what type of structure you are dealing with, and even what the loading was. And we'll do some of that at the beginning of the next period, try to play a little bit the spies and see if we can deduce some interesting things. This being the 787, now if you look closely here, you will see that where it broke, it actually has moved up. Moving up means it was actually under compression. So that means most likely that this wing box was doing a maximum upbending, which would put compression on the upper skin, assuming this is the upper skin and they did not turn it upside down and they're trying to fool us that way. But let's make some assumptions being engineers and see how far we can go. So maximum upbending, and this broke here, and you will see that they're fairly massive. The thickness is fairly high here. Thickness is fairly high means you have a lot of plies, because the plies that make up a laminate are typically 0.15 millimeters. So this may have 100 layers here at the thickest, or 200. I should remember Monday to bring you some examples of really thick composites. It is natural to assume, and in fact tests show that if you apply a load in such a thick structure, the final collapse or complete destruction, as shown here, is not the same as the onset of failure. As you apply load, you will get something to start failing, which usually is referred to as first ply failure. Basically, there will be a ply somewhere in this stack up that will break in a certain way. That doesn't mean that you have final failure. And that immediately brings up a major problem that we have when we do failure predictions in composites. Even if you knew how to predict that first ply failure, how does that relate, if at all, to the final failure, which is what you are primarily interested in? Keep that in mind. We'll come back to this.